I need to shave. I hate shaving though, but it must be done. um, how's it going? I don't know what to do today, so I picked something pretty easy. But we'll talk about that in a second. What's today? Tuesday. Tomorrow is the 1st. I already paid rent. Getting paid tomorrow for my contract job. So that's nice. It's been really freaking hot. I know that. It's like 92 degrees outside or something. Let me see. The temperature outside where I'm at is 94 degrees. What's that in Celsius though? Oh, well, just give me a calculator. Dang it. Oh well. So I'm trying not to go outside. But you know, when it's hot outside, you gotta run your AC more. It costs you more money, but I don't care. I don't know, should we just get started? I don't got much to say. Nothing's really going on, nothing's really changed since Thursday. This is how it goes, I guess. Here's the, oh, I'll tell you what I did earlier today. In this site that is here. So this is a live site, and I've just been working on it. Like, that's what we kind of do every stream. I knew this was gonna, no, here it goes. I switched out the like shell model that you might have seen multiple times on different streams with this avocado model, and the only reason I did that was because the shell model, this thing here, I think it lives in this repo is where I pulled it from. This thing here, it has a lot of vertices on it. It's actually a pretty large file, not like a large asset in terms of like world space. It's actually pretty small, but the amount of triangles on this thing is pretty large from what I could tell. And the larger your model is, the more data you have to send over the wire for somebody to view it, and they're like on the web page. So I just swapped it out with one that wasn't too many triangles. This little avocado mesh, which is also in the same repository, right here, and it's got the same license, I believe. So it was just a quick switch, and then I've updated all the examples for that. So like a lot of these post-processing examples were updated, and they should load faster, because the GLTF model isn't as big. They still gotta do things like, you know, compile shaders and get, in some of these you have to like get the HDR file, which is a pretty big file as well, this texture file. But at least the geometry and, you know, like parsing that GLTF and all that should be a lot faster. I think we can even take a look at, I don't know if this will tell you how many triangles are on the model. Let's see. No, it doesn't. But over here, let me kill the web server for a moment. If you do, I have this tool that you can download for doing GLTF transformations, and it has this inspect option. And if you pass in, let's see, that lives in oh, it's in GLTF's avocado. Yeah, it gives you a breakdown of this thing. If you look at here, I think it tells you how many triangles are on this. Yeah, right here. So should be 682 triangles, this many vertices. I didn't check the other model, but we can download it really quick and take a look. Because I no longer have it in that file, in that folder. But it might be here. It's not. So where is it? I think this is alphabetized, but you gotta know the alphabet. I'm just gonna look for it. Oh. Yeah, right here. Let's take a quick look. Download GLB. Now this thing is not optimized, so it wouldn't be a fair comparison. Let's put it in downloads. So let's go out here, downloads. If we do GLTF, this thing is, yeah, right there. Let's just call it abalone. Yeah, and there's like already like just running this optimizer helped out quite a lot. But if we now inspect it, yeah, so this thing has 6,000 triangles, whereas the avocado one has like 10 times less. It only has 600. Even after all that, like, and both of these were optimized with that same GLTF transform tool. So this should load like, can't say 10 times faster, but it is, I guess, 10 times less complex, I guess. So, I don't know, that was just something that I wanted to do. And that's kind of unrelated to what I did, or what we're going to do today, but I felt like it was interesting enough to talk about. The idea today is that I want to make a bounding box visualization. And the reason I want to do that is because I do kind of want to explore this bounding volume hierarchy. How do you spell hierarchy? This idea, so in the world of computer graphics, it is super common that you need to cast a ray into the scene and see what you intersect with. And a naive approach to that is just to loop over all the triangles, or actually you would loop over all the objects in the scene and test for intersection with that object. One optimization you can do there is, you know, put a bounding box around all your objects and see if you collide with the bounding box. Collision with a box is a lot simpler than collision with, you know, really complex geometry or shape or something. Because all you have to kind of do is check, you know, the faces of the box. I mean, probably even simpler than that. But I haven't researched it. So if you are not intersecting with the box, there's no way that you're intersecting with the object, because the object lives in the box. So if I'm not intersecting with the box, there's no way I can intersect the object. Now it's not enough to say, well, I'm intersecting with the box, and that means I'm intersecting with the object, because you could have something like this, where maybe you intersected the box, but you missed the object. But this kind of works off that idea in that you create this like tree or a graph of these bounding volumes, and you go down the tree to see what you intersect with. But I think if we're gonna do something like this, where we make our own like BVH raycaster and stuff, we should probably do it in parts, so like multiple streams. We won't do it all in one. How's it going? Good to see you. What am I looking at? Oh, Wikipedia page. Just kidding. It's talking about this bounding volume hierarchy, which is a way to do like accelerated raycasting in a 3D scene. It has a lot of use cases. But today I just want to make a bounding box. Yeah, it solves the problem of like, if you cast a ray into the scene, and it doesn't really, like there's all kinds of reasons why you would want to cast a ray into the scene. You know, a very common one is like, maybe you're testing for if I like selected an object, right? Well, you would cast a ray from the computer screen, like, you know, from the viewpoint of the camera into the scene, right? And you would say, what do I collide with? Yeah, and shadows as well. Now, a really naive way to, like, check what you're colliding with or what you intersected is just to check all the meshes or all the objects and then check all their triangles, and that's really inefficient because you're doing a lot of checking that you don't need to do. So bounding volume hierarchy is the idea that you're putting these things in a tree, and you're checking the like bounds of each of these like, I guess, like subtrees and stuff. So there's a lot of like creation that gets made, and then it's like a fast query into that tree. And there's a lot more information out there. Like there's a video on YouTube by this dude that you might have heard of. I think this is how you spell it. Oh yeah, it's right here. So I'll link this in the chat, but he kind of codes up a bounding volume hierarchy. Yeah, this video here. Yeah, if it's more intricate, for sure. If it's got more like triangles you need to search through. Where's the chat? Oh, right here. Yeah, if you're only checking like, you know, let's say you're just checking a flat plane, that's like the simplest case, right? It's super easy just to say, you know, did I intersect with the plane? So, like for example, collisions with like sprites is like trivial. Because all you need to do is just check, you know, intersection with like two triangles. But if you had some more complex geometry that had tons of triangles, then you would have to check, you know, in the naive case, you check every triangle in that mesh, or in that geometry. But today's stream, we're just going to visualize the bounding box of a mesh. And I don't know where we're going to go from there, but I felt like it was a good streaming topic, a simple one at least. But I think my plan is to go and follow along with this, not on stream, but maybe I'll come up with streaming topics, but follow along with this video and turn each kind of like section into maybe a stream or something, and we'll slowly work our way towards making a our own like bounding volume hierarchy, like raycasting system. And in 3JS you can do that because you can overwrite this property on meshes. If you take a look at mesh over here, actually let's take a look at object 3D. So every object has this raycast method right here. Let's search for it. Right here, which is intended to be overwritten, and it is overwritten by meshes, lines and points. They implement their own version of this thing, but it receives the raycaster, and you know, it's like asking, what did you intersect with the raycaster's ray? I guess it passes the whole raycaster in case you need to know information about the raycaster. But if you look at mesh, you can actually go to the source code of this thing and look at the raycast function. This thing is pretty complex, and rightfully so, because it's a pretty complex topic and operation, right? But this doesn't use BVH. This uses, as far as I can tell, it uses just that kind of naive approach. And I guess the reasoning behind that is um, you're only kind of intersecting with just this mesh. You're not doing like a scene intersection. Um, but the Raycaster, I think, also has a way, like if you wanted to check if you're intersecting with multiple objects, I think you can do that on the Raycaster itself. Like I think it does call into this Raycast method, but I have to take a look and find out. There is already implementations of this though. The really popular one is Mesh BVH. Maybe I'll show some examples from this repository. So this kind of, I wouldn't say it's like a solved problem, but this is definitely something that is used in, you know, like large projects and in production projects and stuff. These things at the bottom of this repository. And you can see some of these examples. There's like, the one that I kind of want to work towards is this triangle painting. You know, everybody's playing that Mecha, or what's it called? Mecha Chameleon game. And in that game, you paint yourself, and the way that they do that, they're either probably doing vertex coloring. So when you paint on this, you're like changing the vertex colors of this mesh, and then you're updating, like you're resending it to the GPU and stuff. Or they might be doing like you're painting on a canvas, and then that canvas is mapped around that. Like if you take a look, you can tell I was trying to learn how to play it on macOS, but it's a Windows only game. But you know, maybe you're painting on a canvas texture, and then that texture is just UV mapped over this like model or whatever. So it's the same result. You're just painting on either a texture or you're painting into the vertex colors. So that's kind of where I got this idea. It would be cool to make our own. And then, you know, in this demo here, you can't really change the color of this, but you can at least paint on the mesh. You know, in our case, we'd swap this out with this little guy here, and then paint on him instead. But if you look at the source code of this example, it's, I mean, there's nothing wrong with it, but I always like to do things on my own, because I want to learn how they work underneath the hood, right? This thing lives in collect triangles, this one here. I've looked at this a couple times. But it doesn't have, like, of course it doesn't have the source code for the actual library, it's just importing it from here. But we can use this kind of like as a guide for how to do things, at least for making like an application out of this library. But I think it might be interesting enough just to see if we can program our own, or my own, like bounding volume hierarchy, and see where it goes. It would be cool if like we got all the way to where I want it to be, but you know, with these kinds of topics, they are pretty complex. But I feel like, you know, doing it over a couple of streams would be best, and making it really simple and taking like little baby steps along the way. We'll probably get there eventually. So that's the motivation. My thought with this is, let's just code up, today we're going to code up a little bounding box visualization, and it'll be super easy to do, just so that, you know, it's pretty clear what we're talking about when we say like bounding volume. I guess in the general sense, it doesn't have to be a box. Maybe it's a sphere or something. But you know, box and a sphere, those are both like, in terms of 3D, those are both like volumes. And volume because there's stuff inside of the box or inside of the sphere, as opposed to like surface or something. Let's go over here to the blackboard. I guess it's a blackboard. So let's say, we loaded in this avocado mesh. My plan here's like the avocado and it's got, the seed in the middle. A really easy way to visualize this bounding box, 3JS has a box 3 helper. And all you have to do is pass in a box 3. And then you can just add it to the scene. It's just like, a yellow box around this thing. It lives in 3D, so, it'd be some depth to it as well. This is actually yellow when you can change the color of it, but it defaults to yellow. You can do that, or you can just, there's also a box helper, not box 3, but just box helper. And here you can actually just pass in like the mesh. Or it might be like from object or something like that. But it's so common that you need to calculate these things that meshes and objects also have a compute bounding box function or like method on the class. And you can see that here. It might be on object 3. So mesh inherits from object 3, but compute, where is it? It might be in the geometry. Yeah, I think it's in the geometry. Buffer geometry. Yeah, right here, bounding box. So this is used in all kinds of scenarios. There's even bounding sphere. I can't remember which of these two is more efficient, but for different uses, you might want to calculate the bounding sphere. So it lives on the geometry. So it's not on the object 3D. It's actually on the geometry of a mesh. And you can have geometries that aren't like attached to any meshes. That's pretty common. But I think in our case, what we'll do is we'll loop over this thing's like positions, like its vertices, and we can get that off of the positions. It won't be like its vertex information because that will be like a local coordinate system. We'll instead get its position from its like buffer attributes. And then we'll loop over those positions, and then we will expand this box. Every time we like touch a vertex, we'll expand the box by that vertex. So it'll start out like, with nothing in it, and then as we loop over each of the vertices of this thing, the box will get expanded to contain that point. And we can do this in the render loop. And we can do this, incrementally. We don't have to do it all at once. And I'll show you how to do things like, with the loop that's always running, how you do things, like in steps, I guess. It's something that I learned a long time ago when I used to do like hardware programming. And you only have like one function, or you only have like one processor or something, only one loop, and you have to do things without like delay. You don't want to call delay or something because then you're delaying the whole system. You want things to still happen in the background. It's kind of like a polling kind of system. But you'll see when we do the code how all that comes together. So what we have so far, do I still have it? Yeah, it's right here. This is at playground. Oh wait, what's this? Oh, this is the actual live site. Where's the local host? Oh, I need to run it. Let's see. So at the moment, it just shows that avocado mesh. And let's go into that file. So it just loads that in an effect where right here, so that it doesn't try to do it on the server. Once it's loaded, it resolves this promise here. Once that promise is good to go, you add it, the GLTF to the scene. We calculate well, we have to calculate a box here. So I'm pretty sure this is calling compute bounding box, but this is just for positioning the camera and setting the center of the orbit controls so that it rotates around the center of the box. This function here allows you to pass in a box so that you can like capture things like the size of the box and its center. And then all we're doing is just putting the center, like copying it into the target of the orbit controls. So let's think about how I want to do this. We're gonna know that we're gonna need to, we know that we're gonna need to get the positions of these things. So let's do that. After the GLTF is loaded, we need to look for this mesh because the GLTF only has this scene and it's a group. So we need to look through that group and find this mesh. So after GLTF is loaded, then we'll get out the GLTF and we'll do gltf.scene.get object by name. Did I capitalize it? Yeah. I kind of want this to be lowercase. It's always like, what do you do when you have abbreviations for things? Like this? Do you just capitalize the first letter, or do you capitalize the whole thing? Or what? But this, you can look for an object by name, and the name of this mesh is, like if you log out the scene, you can actually find it. Like somebody else authored this GLTF, so we don't, I mean, I don't know a whole lot about it because I didn't make it, but we can take a look at like how it was parsed by doing, you just log it out to the console, you see like what exactly we are working with. So it's a group and it has children. The first thing, like it should only have one. The mesh is the avocado mesh, and this mesh here will have a name. So this is what we're looking for. It's just avocado capitalized. So let's put that in a variable at the top here. And that will be the object. But like always, we don't know if this object, we know that, you know, either we found it or we didn't. We don't know that it's a mesh though. And I like to return null in the case of like undefined because I've said this multiple times, but I think working with null, you know that you set null usually. There's not a whole lot of APIs in JavaScript that return null. They usually return undefined. So setting this to null kind of indicates like there's nothing there and I set it myself. So if, or we can actually do is mesh of the object. So that's like saying, you know, either this object is, oh, this is now going to return object or 3D or null. here it should be, oh, we don't have this imported. So if it is a mesh, return it. Like in this branch here, it should be mesh. Yeah, okay. Else we're just going to return null here. And I guess in this case, we could just do this. We don't have to, because this will handle the undefined case. Like if you jump over here, you can pass anything in here. And you know, where this comes from, I've talked about before as well. But it's checking to see, you know, is it an object? And because JavaScript is weird and nulls are like actually objects, I guess, it's doing a check for that. And then this is a 3JS thing, is checking is mesh in the object, and if it's strictly equal to true. So that tells us that the object that we passed in is a mesh for sure. And it's a guard function, so it returns not only true, but it returns the fact that at the type level, this thing is a mesh. Or not, you know, whether it is a mesh or not. Oh, and we don't want to return object here, we want to return, so maybe we should call this get mesh. Do I have a get mesh? No, I don't. We just do things with the scene. So we'll call this get mesh because it returns mesh or null because it couldn't find it. And once we get the mesh, then we can get its, I'm gonna separate these two because we might want to do things with the mesh. And here we can call get mesh and get the mesh out for different reasons, or like to do different things with it. But here we're gonna do position attribute. After we get the mesh, we'll get out mesh here, and we'll just return mesh.geometry.get attribute position. Could be null, so we'll do that, and then we'll do that. Yeah, I think that's right. And we could also do this to make it more obvious. Oh, here we can just return mesh. I don't know, that looks better. It's strangely enough, like this doesn't return undefined. It's not typed to return undefined, so I guess a mesh always has, well, I don't know, because if you put in like some bogus thing in here, it just assumes that the mesh, or like the geometry has that attribute. But it should have a position attribute. I hope. I mean, it should, because we can display it in here. Okay, so now we have the position attribute, and now we can loop over the positions. So down here, we'll keep track of an index, started at 0. And then we want to do this like every, you know, second or 500 milliseconds or on some kind of interval. So let's call this interval milliseconds, and let's just set it to like 500. We're gonna keep track of the last time because we want to get the difference between when these, like when the first loop ran and then the second loop and then the third loop. We want to get the offset or the difference between these things. So last time was 0 time, so we'll do diff. And I think this animation loop runs at 60 frames a second. So console.logging the diff here. Oh, and we gotta make sure we do last time equals time. Oh, it needs to be a let. So console.logging the diff here should show like 1/60 every time. And that's what it's showing here. So it's in terms of milliseconds. And if you do, let me turn off the log. 1/60. So that's in terms of seconds. You take that and you multiply it by 1,000 to get into milliseconds. And so this is running 60 frames a second. I don't know if it's like set up to run at your monitor's refresh rate or not. I don't know if it's like all that, but it's probably in the docs somewhere. So we have the time difference right here. Now we want to add that to like an accumulated time. So we'll do let accumulated time equals 0. We'll take accumulated and we'll add the difference. And then we can check if the accumulated time is greater than or equal to the interval. And that means we need to do something. That means, you know, we ticked up, or let's see, can I draw this? I don't know. But here's where we want to be. Here's where we're at. Every like frame, we're adding a little bit of like, we're stepping closer and closer until we go at or above, you know, the interval right here. That's our trigger for when we need to start doing things. So we just add to that accumulated time until we reach the interval. Once we reach the interval, then we set accumulated time back to 0, and we increment I, or the index. So if we log out, let's actually log it out. So index starts at 0. Let's log it out on the first time right here. Now it should increase by 1 every 500 milliseconds. Or let's do like every 2 seconds so that we can see it. I don't want it to be too fast. Right here. Oh. Accumulated time. Yeah, so every 2 seconds it's increasing by 1. Oh, I guess this happens on the first time around as well. Because it is equal to the like they're both equal to 0 initially. We can see like it's incrementing every 2 seconds. If you decrease this to like 500, it should be, you know, every half second right here. So this will be how we control like what point gets added to the box, the bounding box. We're just going to increment this index. And then here, instead of, you know, just adding to it, we'll get the position. So we need a box for this, so let's do that. And then what else? Oh, we need to add a helper to the scene, so we'll do box 3. We'll call it helper. And where's the scene created? Somewhere up here, I think. Yeah, let me take these together. So we'll add it to the scene. Oh, it needs a box. And it's an empty box initially, so we won't see it. But now we can expand this box by whatever vertice we're looking at. Vertex, not vertice. Okay, so in order to get that, the positions are vector 3s, so we can just say position equals new t dot vector 3. And in vector 3s, you can set from a buffer attribute. So you can do v dot set from, let's see, it's position dot set from, or let's see, is it buffer? Oh yeah, from buffer attribute, and we pulled that once we got it from here. But this is a promise, so we should probably put this behind that promise. We can do that. That's easy. Oh, let's call this like get position attribute. I like to, if it's like a promise, I like to put a verb in front, because then you can read it like get position attribute dot then. After we get the attribute, then what do we do? What does this give us? The position. Okay, there it goes. So, if this is null, meaning we couldn't find the attribute, we'll just return early. Otherwise, we can return this thing here. I'm gonna clean it up a lot. Delete that. Oh. I probably need to close something here. Alright, let's see. You can't call it position, so let's call it B for vector, I guess. And this is position. Two arguments, but got one. What else does it want? Oh, the index. Yeah. Okay, so now V is holding that position. Okay, let's see. So I don't think we need to return this. It will just return when we exit the thing there. So yeah, that makes sense. So now V is holding that position. Now we can expand the box by that position. So that's box expand by point. And that makes it seem like we should call this point. Okay, there's the box there, but it's not expanding. Oh yeah, it is. It's like really slow. So let's set this like 100. Get rid of this so it's easier to see. So every 50 milliseconds, it's expanding by some point in this geometry, and it's based on the geometry, so it doesn't handle any kind of like transformations to the mesh, like scaling and rotating and stuff. It's strictly based on the geometry. So one thing we need to do too, I just remembered, is that this can go out of bounds. So if we'll do if the index is greater than or equal to the number of positions, and you can do that by position count. If that's the case, then we'll just set index to 0, and then we'll make the box empty. Otherwise, we'll do all this. And let's make this like really fast. And once it's like done looping over, it should, yeah, reset. Let me check the logic here. So we add to the accumulated time. If that is over the interval, then we'll set the time to 0. I kind of want to do this last. This is like the final thing that we do, but yeah. So we hit the point where we're over, so we'll check the index. If it's greater than, I think I want to do this as less than, and we'll flip these. So kind of like the reset happens here, and the reset happens here. Not really a reset, but a reset on this one at least. Yeah, so if the index is less than the count, that means there's still positions to go through. Then we'll get whatever position here, and we'll expand the box by that point. Otherwise, there's no more positions to go through. We've already done all the points. We set the index back to 0 when you make the box empty. But we always set the accumulated time to 0, and we always are incrementing the index if we're inside of this if branch, or like if block. Now let me make sure that matches with my notes. Yeah, it looks like it does. Well, not 1-to-1, but close enough. Okay, so what I want to do now too is handle any kind of like transformations to the mesh. So we'll actually need to get a hold of the mesh. We can either get a hold of its matrix, like a reference to its matrix, or we can change this so that we're only getting the position here. And I don't think we need the position attribute for anything else besides doing this. But we can try it this way. We'll say get mesh matrix. And this kind of shows you like why breaking out get mesh into its own promise is sort of kind of beneficial. But same thing, we'll check if the mesh is null, meaning that we didn't find it by its name. If we did find it, mesh here will not be null, and then we can do mesh.matrix. So here we need to wait for both of these promises. So we'll do a promise.all, where we get the attribute and then we get the mesh matrix. And that will go here. And then we can actually apply a matrix to the position. Or, yeah, this should return the vector 3, so we can just do the apply matrix 4, and we'll just pass in the mesh matrix. Oh, I called it matrix. Let's call it mesh matrix. So now if you rotate the mesh, like up here where we load the mesh, right here, we can do this. Actually, we can just do it here because it doesn't matter if it's a mesh or not. All that matters is that it's an object. So we'll do rotate along the X. We'll do like quarter of pi or something. And now it is like getting, you know, it's, knows about that matrix transformation. So without that, it will try to get like the geometries. I mean, it is getting the geometries position, but it doesn't know that it's been transformed. So like it still thinks that it's right here. But all you have to do is just transform those points. I think you can also take the entire like buffer attribute and transform it. Yeah. That's interesting. So you probably don't want to do that because well, you might have a reason for doing that. In this case, it doesn't really matter, but this will transform it on the geometry level. So that means that like if you had multiple instances of this mesh or something, it's having each one of those, if they're sharing the same geometry, every single one will get like updated or transformed. Now if you're using like instanced meshes, those all have their own matrix, which you can set and get right here. And they all have like their own transformations and stuff. And their own colors, so that's pretty cool. But I think this is using like instanced buffer attributes or something to do that. But that's kind of outside the like off topic. But anyway, so like we could transform the geometry up here instead of the mesh. What's this not like? Oh, this could be undefined. But I'm just going to transform the points themselves and leave the geometry alone. So here, still have error? What's the error? Oh yeah, it could be null. So if that's null or mesh matrix is null. Now I want to kind of visualize like what point we're currently at. So we could, you know, put this geometry into a points material and visualize the points, but that will show all the points all at once. And I don't know, it might be possible, but I don't know of a way to change the size of points. But we can do something simpler, and we can use like a sprite or something and just reposition the sprite wherever, like at the same position of the point that we're currently expanding by. So we'll take a sprite. So let's plot point. And sprite here, take some materials. I thought it took a geometry, but how do you do like a flat? I don't know, do you have to pass anything in here? Okay, so it's just a square. Well, I guess it has a default texture or something, or a default material. Yeah, let's see. Sprite material. Okay, so the map is default to none, or null, but the color is white. And then its geometry. Does it have a geometry? No. Oh, this is material. Let's take a look at sprite. Okay, it has the geometry, but not in its constructor, I guess? Yeah, I can only pass it in material. That's weird. And then this is a plane geometry. I'm pretty sure. Well, I mean, I'm definitely sure because we see a plane here. But yeah, let's just roll with this for now. We can make it a circle or whatever later on. But at this point, you can tell it's like way too big. So before we scale it down, let's move the point like this. We'll take, I guess we'll call this sprite. We'll take the sprite and we'll set its position. We'll just copy over whatever the point's position is. So that's working, but it's like way too big. So to scale it down, you probably want it to be scaled by some multiple of something else in the scene. You don't want to like hard code it necessarily. At least I don't. I just want it to be some like factor of the dimensions of the avocado. So here where we get the GLTF out, actually where we get the mesh out, because I want to get a hold of its now I think we can do it on this box thing right here. So we get the box and we'll get its size, but you can actually pass in a size here. So that, because it has to calculate the size anyway, you can pass in a size vector if you want to like capture it. We'll pass that along, and then what we can do is get the like minimum or maximum of the size. So we'll take the difference. That's going to be size.max.sub size.min. If we do it this way, then we don't have to worry about negative numbers. So you could also do min minus max, but then you'd have to take the absolute value. So you get a positive number, but here we can do, we'll take the minimum of that, and we can spread this out. It has a spread symbol on it. That's another thing that's kind of off topic, but you can actually write like behaviors into your classes for like what happens when I try to spread this thing. And it's sub. It is sub, but why can't I sub this? I forget what this API is. Oops, clicked the wrong app. Let's see. So I have it in my notes, just in case something like this happens where it doesn't work. Oh, okay. So size is a vector. And size is positive always. So what size really is you take the box.max and you sub box.min. But that will modify max here. So you can't do that. You have to make a copy of it, or you have to like, put it in some other place. I feel like I'm not really explaining that very well, but calling sub here modifies the instance. So we can't do that, but size has already got max minus min inside of it. So we'll just take the minimum of the size. That's going to be for X, Y, and Z. And then we'll take the sprite and we'll take its scale. We'll set scalar to be some multiple of this minimum. This will probably be too big. So we can, multiply it. I guess divide it by some other number. And it's like way too fast, so let's slow it down. And then here, it might be better to visualize, or like to show the wireframe of the, what do you call it, of the mesh. Or we can just set the mesh to be invisible for a moment. So whenever we get the mesh out here, it won't like this, but oh, it is very small, but it's right there. So let's make it a little bit bigger, maybe 25. We could also do this. We'll do object.wireframe earth on the materials. So maybe it makes sense to create a way to get the material, like as a promise. Let's do that. How do I want to do this? So when we get the mesh, we'll do dot then, we'll take the mesh. We'll do mesh.material, but this can be a single material or an array of materials. So let's call this material. This could also be null because maybe it didn't find the mesh. So we'll check if it's an array. If it is, then we'll just pass, the first object through, or the first material in the array. This should be a question mark. Or we'll do mesh.material. In this case, it's going to be a material. This could still be, yeah, undefined. Because I have a setting turned on for no indexed, it's like no unchecked index access or something like that. Meaning that if you try to access, try to do this, it's going to say that this could be undefined. And I won't go into reasons why I like that setting, but you can Google it or something if you want. So In this case, it's undefined. We just wrap this whole thing like this. And now it's going to be that or null, and we'll just return that. And then in that case, we don't have to wrap this at all. We can just... Can we do that? Mesh is possibly undefined. Okay, that's good. I kinda don't like having this on both sides, this, or like this mesh question mark. And you know, for readability, which does matter, I think, you know, I kind of like reading things vertically. So this, I like this more. And then here, mesh will be defined, so we can just return whatever this is. But we don't have to check for that, and we don't have to check for that. Okay, so if that's done right, this should return, oh, but it said returning undefined, and that's because this could still be undefined. So, I'll do that. Okay, not very pretty, but it works. What? What? Oh, crap. One second. How do you do this? There was a nice... Every time this happens, you know, I have to do it like this. And I paste. I hate that. Okay, so let's make this one line by doing this. Oops. Yeah, that looks a little bit better. Okay, so what we're doing, yeah, we wanted to show that this, let me set like the wireframe of this thing. So get material.then material, we'll say material wireframe. Oh, and this is another tricky part. So this is just a basic material, or null. But a basic material doesn't have a wireframe property on it. So we need to check for that too. And I've been thinking about like ways to fix this. It's not really a problem, but it's the same idea of like with JSON. You have like a JSON parser, and then maybe some validation library on top of that. It would be nice if you could create like a schema for this thing, pass it through your schema, parse it, you know, like with Zod or Valibot or something, and then if it passes the parsing, then whatever you get out, and take Valibot for example, you can do a safe parse, and it's a union of two different outcomes, whether it parsed correctly or whether it didn't. And in the case where it parsed correctly, you have a result property on the returned object, and that result is strongly typed to the validation schema. So it would be nice if I had something like that I could use instead of doing all this like null checks and stuff. But I gotta think about that. In this case, at least, just to check that wireframe is on there. We know it's, well, I know it's a standard mesh material, but TypeScript doesn't know that. But you can kind of get away with it if you do wireframe in material and material dot, or I guess you could do type of material dot wireframe is Boolean. Then what you could do here is material dot wireframe equals false. Oh, it could be undefined, so if material, or not undefined, but null is null, then we'll just return. Now, I was expecting that to work, because it's a reference to the meshes material. And you don't have to set like needs update to true or not. You can just set the wireframe to true or false. Where do we get the material? Right here. I have a feeling it's something to do with this logic. So let's take a look at the wireframe. Oh, I need to set it to true, duh. Okay, there it goes. So now you can see kind of through it. Another thing you could do is like set its transparency or something. But I think this is good enough for now. You can see it going through each like vertex of the mesh here. And it's cool because at the end, when it gets to the top here, it does like the seed right here. It'll be a while before it gets there though. But if you take a view of it like this, and then the white dot will jump over to the seed. Should we wait for it? I guess. And the other cool thing about this is that the seed is like part of the avocado. You can tell like there's no, like you can't pull off that avocado seed or whatever. It's all like one geometry. So that's where it's going through the seed part of it now. And when it's done, it'll collapse down to like an empty box again. But even doing this, I don't know if there's a way to speed this up, because you can tell like all of this will be in the box, but it doesn't know that. It still has to check it. So it still has to loop over like every single vertex or whatever. Maybe when we get this thing to be, you know, we do the raycasting. No, I'm not sure. I don't think that'll help us. But it would be nice in this case, like if you could say, well, there's no way that I need to check this, you know, some of these triangles or something, because they'll lie inside the box. I don't know. I don't know if that's possible, but might be an optimization to be had here. But for mesh with not a whole lot of vertices, like this thing is pretty quick. You know, if we even just set this to like 1, or let's set it to like 0, it should do it like instantaneously. Maybe not instantly, but it was pretty quick. It's a lot quicker too if you're not doing this loop, you know? Let's set it back to like 250. So the other thing I want to do before we call it a day is add controls for this, where you can set the time, or the interval, I mean, and you can set, you know, turning on and off the wireframe. So that should be pretty simple. So we'll put this thing in a div, and then we'll import the pane container component. This div here needs to have a class of absolute, because we're going to absolutely position the pane container and put it at top 2 and right 2. And we'll put an attachment here. Make a new pane. Pass in the container, and then the title, I guess, will be controls. And we should dispose of the container, or the pane, I mean, right here. Oh. Didn't position it where I thought it should. Oh yeah, this needs to be flipped. Relative, and this is absolute. Absolute. No, wait. Why isn't that working? Oh, gosh. I wish there was a, way for it to tell you, hey, you misspelled this class. There probably is. Okay, so down here where we get the material, yeah, we just need to, I just want to move this down here. So after we get the material, we do the setting. Instead of doing that, we'll do pane dot add binding, and we're going to bind to the material and its wireframe property. I'm going to give this a label of wireframe. But now that this is in a promise, we should say like add wireframe binding. Once this promise resolves, then we can do the disposal, because we don't want to dispose of it and then try to add something to it, and it not like be there or something, right? So we'll dispose of it after we've added all the, like after we've done all the asynchronous work. So if I click this, yeah, that works. So we can turn on and off the wireframe. We could see through it now. You know, and it might, I don't know, maybe we should do like a transparency thing. I don't know. I think that should be possible, but we'll have to do, let me log out the material in here, because I think there's 2 properties that you have to set. I just want to see if this looks better. Let's see. So there's a transparency, yeah, right here. And then there's a alpha. Or no, it's opacity, right? Opacity right here. Let me put the music back on. So instead of doing that, what we need to do is check for opacity in the material. Actually, let's do the transparency first. So if transparent, is in the material. Oh, okay, it's already there. So we can do transparent equals true. And then does it have opacity? Yeah, it does. That's nice. So we don't have to do this then. We can just do material dot opacity. Oh, this needs to be a number. So if I give it a max of 0 and a min of 1, and we'll say the step is 0.1. Oh, what happened? Yeah, I can't like control this thing anymore. Oh, I have these two flipped. Max of 1, min of 0. So now you can see through it. That's cool. I kind of like that more. Let's set the opacity to like 0.3 initially. Maybe 0.2. And then to control the milliseconds, that'll be really easy too. We'll go up here, we'll make a little object for that. And down here we'll do pane.add binding for the interval and its value property. Speed milliseconds, like this, I guess. We'll say min 0, max of like 500, I guess. Step of 1. And then here we can just get rid of this, and this will be dot value. So if I change this on the fly, it gets a lot faster, and I can change it to be a lot slower as well. And then, you know, we could turn on the wireframe and the opacity. Like, we can mess around with both. So this is no longer add wireframe, this is add material bindings. So maybe we should have kept that if check from earlier, but we'll check if wireframe in material and material.wireframe equals type of needs to go there, so that should be number. We'll do pane.add binding material for the wireframe. Label is wireframe, that should be enough. Oh, not number. Boolean. There we go. Alright, that works. And then, I don't know, I've been favoring like, what do you call it? The early returns, so I kind of want to do this instead. Oh, but that doesn't look so great either. And it put the knot on the wrong thing. Okay, so if wireframe, yeah, this knot should be on this whole thing here. There we go. But that doesn't look great either. So maybe put it in a, I don't have a good way to select this. Okay, so if not has wireframe, has I don't know, that's a little bit better. I want the return to be up here too. This is so arbitrary, but that's okay. Oh, but it needs to be in this if statement because, you know, checking for this is telling TypeScript that wireframe exists on this guy. Hmm. You know, if it's like, in that case, I could just go back to what we originally had. Which was this. Okay, it ain't the prettiest, but it works. Now, the only other thing I might want to add to this is the oh, you know what? I just thought of like doing that like matrix transformation stuff. If you like rotate this thing inside of a group, like you rotate the group, let's say that you had the mesh as a child of a group, and then you rotated that group, you would have to look at the group's rotation instead of the mesh's rotation. So this isn't foolproof here where we do the apply matrix thing. I'm going to leave that off. Because what you'd have to do is get the transformation matrix of like, you know, all the rotation and translation and whatever for every like parent. You know, make some big mesh out of, or make some big matrix out of that. And I don't think we're rotating it anymore, right? But I think this is good enough for a demo. If we wanted to add a way to visualize the points of this thing, you could just pass the geometry to a points material. Or I'm sorry, a points. I think it's just called points. But you could do get. Do I have a get geometry? I do up here, so let's do. Here, but we get out the mesh. We'll check if the mesh is null. If it is, we'll just return it. Otherwise, we'll return mesh.geometry. Here, we can just say get geometry. If geometry is null, we'll return it. We can do that instead. Oh, this is a get position attribute still. Right. What's it not like here? I need to change this one. So now that we have a way to get the geometry, we can do create points. So we'll do get geometry, but then geometry, and we'll do const points equals new p.points. Pass in the geometry, but it could be null. So we'll do if geometry dot, or if geometry is null, we'll return it. Or here, yeah, we'll return null because here we're returning something. In the case where like we don't return anything, I just like to return. I don't return null, I just return. But you know, this is returning something. It should be returning points, right? So we'll do new t.points, and then we can just return that. So now we can do create points dot then get the points out here, and we'll add them to the scene. Scene dot add points, but again, this could be null. And this is actually add points. But you know, we're not returning anything here, but we're not cleaning up either, which we should be, but I'll do that off stream. And strangely, like the points of the geometry, yeah, I think this geometry has, or not the geometry, but the mesh for some reason has a rotation on it. You can tell like this thing is rotated along the y-axis by half of pi, right? 180 degrees. I don't know why they did that, but it's actually should be finding the box for the points, and you can tell that the box is kind of like not really easy to see, but I don't have a way to really show it off. Maybe if we used a orthographic camera. But I'm trying to think how best to do this. And we could rotate the mesh to be back in line with the geometry. Maybe that's what I did in my notes. Let me take a quick look. Is there any rotate? No. So the easiest thing to do then probably once we create the mesh, or once we get the mesh, here, before we return it, we'll just rotate it. Rotate it by half of pi. Or is that right? No, it needs to be full, a full 180. So it's not half of. Is it? Yeah, it's half. It's not that pi. There we go. So now we're seeing the back of the avocado, which isn't as interesting, but we can, you know, move the camera to where it needs to be to make up for it. So I think the final thing to do now is to make a way that you can like turn off the points. You know, you can have a way to like You don't have to set visibility of this thing to true or false, but you can on the points. I mean, it's very hard to see the points though. They're like so small, but they're there. I mean, I can see them from here, and I'm probably like 3 feet from the monitor, which is almost a meter, right? Maybe I should start using. Uh... oh, I didn't. I had the stream on a different monitor. I wasn't looking. Yeah, it looks like a point cloud. Yeah. Oh, okay. Yeah, don't worry. You don't have to be active or anything. Oh, okay, cool. Yeah, well, I thought about getting a projector. That would be nice. Like right in front of me is just a blank wall. So if I had a projector, I could like project. I just got a Switch 2 the other day. It'd be cool if I could project like Mario Kart on this big wall right here. Oh, it's really old. Oh, that's neat. I remember when I was a kid, they had projectors in, school, and this is like before they had like tablets and stuff like that. But you would write on like a transparent sheet and like with a marker, and you would project that onto like you pull down from the whiteboard. You pull down this like big flat like canvas or something, and you project up on there. I thought if I can get one of those old projectors, that'd be pretty cool. Like imagine if I was doing stream with that like right here, and I was writing things out. I do have a tablet, but I haven't hooked it up yet. Like set it up for streaming because using Excalidraw over here, like I just do things with the mouse, and sometimes I can draw nice shapes, but other times it looks like, what do they say, like really bad. It's loud and stinky. What the heck? Do you know how old it is? Well, if it's for the Super Nintendo, it might not be like super old. Oh, okay. Oh, yeah. Oh, okay. So it's like, it wasn't made around the same time as the Super Nintendo. It's just what you're going to use it for. Or maybe it is made for the Super Nintendo. Where are we? Okay, so the last thing I want to do is add a binding for the visibility of these upscaler for the. Oh, okay. Do you know what what Super Nintendo games are gonna play? Very sad. Let me guess. Probably Zelda or something, or maybe like I don't know. I'm kind of interested to see like what homebrew games are out there nowadays. Super Mario Kart's pretty fun. Um, if I had a Super Nintendo, I would probably be playing Earthbound right now. I've heard of Chrono Trigger, and I was watching some VTubers play it a while back. Uh, it's supposed to be like really good game. It's supposed to have a really good story and stuff. Um, can I put on the soundtrack? Like the jazz version? I'll do that next stream, but you have to remind me. Yeah, there's this site that I use called Kin in I think it's called Kinsider or something. Well, I have it brought up right now. So this is the site that I use for the video game music. Uh, and I'm sure they have that album or that soundtrack on there. Oh, why did it put downloads in front? Yeah, so I don't know. I just look for. I usually just You like click on one of the platforms and then I just go to the top 100 albums and just find one that sounds decent. This game, what we were listening to today, um, is a Neon White, and it came out a couple of years ago, and it's kind of like a speed run kind of game, kind of like Mirror's Edge or uh, that sort of thing. But if I remember, I will put on Chrono Trigger next stream. Tent configurator for, you mean like tents for outside, like for camping and stuff? Oh, okay, okay, I gotcha. Those things, have you seen videos of those things? Like on a really windy day, if your tent isn't properly secured to the ground, it will just blow off, like blow like, you know, into the neighborhood or just into the parking lot or whatever. It's kind of silly. Oh yeah, I've seen the ones that they put into the like they're like stakes in the ground and you hammer them down into the ground really deep. Um, when you like wrap like rope or something around the stake and tie it really tight and just hope for the best. Where do we create the points? Yeah, right here. So here we'll do the same thing, but I don't know. Do I want this? I don't know what to call this. If I put this in a everything is standardized. It's a lot better here there than it is here. Like here it's just like do whatever you want. You know, that's that German engineering they always talk about. Oh, I live in the U.S. Yeah, we do. I just feel like there's so much uh like, I can go to Walmart or something and get a tent. And it's sure it's like standardized, they're not going to sell something that would like, have hazardous materials into it or something. Um, but I just feel like the quality wouldn't be as great. Like there's no quality control. Well, there is to an extent, but um it's like I wouldn't buy an American car. I'd rather buy like something like an import or something, right? Um and I feel like that's the same with other things. So this needs to be a promise, not all, because we're gonna wait for the get material and we're gonna wait for the points, or get points, or no, what do they call it? Create points. Okay, so that's the first thing we do. Um, then we'll do if. The reason why I want to put this, well, no, let's do this. This doesn't have to be this way. We can do that, and then we can say const add points bindings equals create points. I always put that as a function call, but it doesn't need to be. So we'll do points, and then we'll add a binding for toggling the um, points visibility. So we'll do pain.add binding points, and then it's going to be its visible property. We'll do points visible, and maybe I'll put this in a folder or something in the pane, but we'll just get it working, and then I'll probably in the stream there. So points could be undefined, so let's handle that. We'll just return. Okay, there it is. And then in this function return right here, we'll do promise.all. So we'll wait for these two things. Add material bindings and add points bindings. Yeah, there we go. So make sure that this works, and it does. So they're sharing the same geometry. So if we do transform the geometry, both of these will get transformed as well, which is nice. In this case, I guess. You don't really want to do too many transformations with the geometry because, well, you kind of want to do all your transformations up front. You don't want to do them in like an animation loop or something because it's really slow. So I've talked about this before, but if you're doing transformations like scaling and rotating and stuff, you should do that on the mesh because they're probably implemented as a uniform in the shader. I don't know that 100%, but I'm pretty confident that it's the case. Because if you transform the geometry, then you would have to send that new information uh, to the GPU every frame, like if you were doing it in an animation loop or something. So that about does it for this little demo. Um, this will be like, this kind of looks like a Christmas tree right here. Kind of, sort of, with the points on it. Looks like little like lights on a Christmas tree or something. Um, so where do we go from here? Well, this was just visualizing the bounding box. Um, Once we have these boxes, then that's where we need to start creating the volume hierarchy, where we, add these. I guess we'll do it at the triangle level. So in that case, you need to add bounding boxes around, sets of triangles and stuff, all the way down to one single triangle. Uh, I haven't thought too much about it. I just needed a topic to stream today. But I think we'll come back to this on Thursday. And I got some research to do in the meantime. Um, yeah, I just see where that video takes us. So that's it for today. Um, I will try to stream again on Thursday. Got my day off on Tuesday, today and Thursday, so hope that you guys come back. Thanks for chatting, and hope everybody has a good rest of their week and good weekend. And if you're in America, happy 4th of July, all that good stuff. Thanks again for watching, and I'll see you guys next time. Oh, should we raid somebody? I always forget to raid somebody, but I don't know. Yeah, the 4th is when we celebrate. Uh, well, whenever America like separated from England or Europe or whatever. Yeah, I'm just saying like like if I don't come back or something, if I don't see, I don't know if anybody's here besides you and me, but I don't know. I always just pretend that there's more than one person, like there's multiple people in the audience or something. Yeah, and if you're in, I guess that side of the world, it is already the first. Um, yeah, Independence Day, that movie. I haven't seen that movie, but supposedly it's like a classic. There's so many movies I haven't seen though. I don't even know where to start. But I do like sci-fi movies, so maybe I should watch that. But I am going to call it there, so I will see y'all later. Yeah, there's a lot of that's how it is for action movies. They love that kind of stuff here in America, you know. Okay, take care. See you later.